In this video, I will take you through the basic steps of creating a research trail with our Excel macro with Pajek and with a program called Draw.io. I will show every step of a research trail with data from the Web of Science, but I will also show how to include metadata from Crossref, full-text PDFs, and patents. There are several steps that we will go through together to make a research trail. I will start with some technical preparations, including downloading the necessary software and the settings in Microsoft Excel. We will then go through the steps shown here in this flowchart, beginning with searching for publications from our researcher online, over processing these publications and getting them into the right format, to running the macros in Excel and drawing the picture in Pajek, the subsequent refinement of this picture, and eventually the finishing touches of the research trail in assigning topics to clusters. This is also the same structure you will find in the written manual that you can download together with the macro package from the GitHub page linked in the description. I would recommend to just download the whole zip from the GitHub repository. You can do this here, download zip, save it somewhere, for instance on the desktop. Then you just unpack it. Here you will find some files, the already mentioned manual, where you can find everything that I'm talking in this video written down. You will find two useful templates for a later step and the Excel file with the macros. The first time we open it, we need to say that we trust it. So we press here. And we also need to enable macros. You should go to the options and then Trust Center settings. Macro settings, and then enable the VBA macros. This is necessary that it runs. Press OK. In some cases, you might get an additional warning for downloaded Excel files with macros from the internet. In this case, you need to get into the Windows Explorer, get to the properties of your Excel file, and enable that you trust the author of this file so that you can use the macros. And then it's set to go. All right. Now that the technical preparations are done, we can begin with the work on the research trail itself. The first thing we need from a researcher is, in the best case, a complete and accurate publication list. Those can often be found at their or the university's homepage, so we start to look there. We usually do this by Googling them. In the best case also, if we know the university, this helps. In this case, it's the first entry. And here we can get some background information, which will be useful later, and also a publication list. What we can already see is here that the most recent entry is from 2018, which is 5 years old by today. So this is probably not the most complete publication list, but it's a start. If we can't find everything we need here, another valuable alternative is also ResearchGate, where we can also look for our researcher. In this case, Erika Larsson does not have her own ResearchGate site, so this might also not be a comprehensive list. And a third, but usually a very good place to look for publications is Google Scholar. Here we can find a user profile with a verified email, which is usually a good thing. And sorting it by year, we can see that we have quite a few entries here. So we get 56 entries starting from this year or last year going back to 2001. And just to be sure, it makes sense to check for consistency between the lists. So the earliest one we have here is from 2018 on differential occupancy, which we can also find here. So we can be somewhat certain that this is from the same researcher. And what usually also helps is to save some additional information on the researcher, for instance, CVs, if they are available. So we download it here. And then in the best case, we make a new folder for our researcher just to save all the information and also to download later on the files for the research trails. Now that we have a publication list, we need to somehow get to the publication data that is needed for creating a research trail. So that means things like title, year, authors, and very importantly also the cited references. In this video, I will talk about 4 ways to get the data from our publication list into a format that we can use for creating a research trail. The first one will utilize the Web of Science. The second one will utilize Crossref. The third one will work with full text PDFs and a site called Growbit. And the fourth one uses patents. We start with the Web of Science. So what we do is we go to the Web of Science and we look for publications by author. So we choose author here in the field and write the name of our researcher. And for instance, here we get 44 results, which we then need to check with the list, in this case from Google Scholar, to see if these are really articles by our researcher. One way to do it is, as I said, to check it with the list. So we see if the title is the same. If you don't have such a list, what also usually helps is to look for the co-authors and to look for affiliations. For instance, here we can also find that the first name is fitting, which is a good sign, and we can see that she is with affiliation 5, which is Brown University, which is also the correct university, which also is a good sign. So we can be reasonably sure that this article is really by our researcher in question. So we check it, and we do this now basically for all the articles that Web of Science proposes here. We check if it's in the list. Some publications will not show up in the Web of Science. For instance, this one. Here we can already see an indication of why this is. This is an ahead of print article, which means it might show up later. And indeed, also in the Google Scholar version, it's up here again. And in the Web of Science, we also have it as the second publication. But the one below is a preprint, which is visible because of the place where it's published, bioRxiv. This means it is not yet published in a journal, and preprints are also one of the publications that are not indexed in the Web of Science. We can also include those in the research trail, which will come a bit later. But for now, we cannot include it as it's not here. Sometimes we have publications without references. For instance, in this one, this is a meeting abstract from a conference. Those are usually one-pagers just with the abstract of a talk. We need to decide case by case if we want to include those in the research trails. For now, we can leave it in. Sometimes we also find double entries. Here in this case, this is also a meeting abstract. If we decide to include meeting abstracts, we would only include it once. Okay, we went through the list. We selected all entries but one because it was a double entry. If you would not include meeting abstracts, this one would also go. This is in a way the best case, which is related to the name of the author. The more common names they have, so Smith or something, the more authors you will get with just a similar name that the researcher you're interested in, and then you have to sort out much more articles. In this case, it was fairly easy, also because we had a publication list to compare it to. If we are satisfied with what we've chosen, we go to Export here, and we choose Tab Delimited File. Then we see that we have checked the first option, the selected 43 results. And for record content, we need full record and cited references. So the full record does not include the references, which is important for our method. So this is not enough. We could also go to custom selection, but full record and cited reference is faster and includes everything we need. So we select it, press export, and then we get a text file, which will be downloaded, called saved recs. It's always called saved recs. So if you do it more times, it will just have the same name. So we put it in our folder again and rename it to the name of our researcher. But downloading the necessary information from Web of Science is not always possible, since the database is a proprietary one and not everybody has access to it. There's a viable alternative. You can also use Crossref, which is an open access site that also stores metadata about scientific publications. You go to crossref.org, go to search metadata, and put in the last name of your researcher again. This works not very well in every case, but at least in this one, you get some valuable results from it, which you then again have to check with your publication list that you have from Google Scholar. This is basically the same process as I showed before in the Web of Science. So you check last names, you check affiliations, and if you find some publications that you are satisfied with, you go to Actions, metadata is JSON, then you get to the JSON file, which is the metadata scored. You go to Save, go into the folder that you have before from your researcher, press Save. Now you repeat this for as many papers as you want to include in your research trail. So if I'm basing one purely on the Crossref, then I would try to get as many as possible from the publication list. If I want to check if there are some in Crossref who are not in Web of Science, which is sometimes the case, especially in social sciences, less in the natural sciences, then you can just download those. So again, Actions, metadata as JSON, and Save. Now, since the data downloaded now is in a different format than the one from the Web of Science, we first need to reformat them to be able to use them together for the research trail. This already happens with a macro. So we use the one we downloaded before from GitHub. Let's put it in the same folder. That's always useful. You open it. You again have to press Enable if you didn't already do it before. Then you go to View, Macros, and then you choose the very first one, Add Crossrefs. Press Run, and then you choose as many JSONs you've downloaded from Crossref as you want. You press Open. It will work a bit, and then you might get this window. This means that the macro looked into the stored metadata in the JSON, which sometimes refer to other JSONs, which it would then automatically download from the internet. Sometimes it is in a structured way, so it can automatically read it, and sometimes it is like this
So the reference in the Crossref file is just a string, which the macro isn't able to read. So for some references, you might need to do it yourself. So there's certain fields that we need to compare the references to. The most important ones are the last name of the first author, the year, and the title. So this is usually the journal or the book where something was published. In this case, it's bioRxiv. You would save this in the volume. Then we press submit. The macro works a bit, and now it gives you another one. Again, last name, year, journal name. Since there's no volume, starting page or DUI, that's it. And so on and so on. Now, sometimes you get references like this, which is just from a web page. We wouldn't include those, so you press on cancel. Now, how long this whole thing takes depends on the quality of the metadata in Crossref for the files you downloaded, but eventually you will be finished, and then it will ask you if you want to add this to an already existing Web of Science input output file, or if you want to make a new one. Let's now say no, so we will create a new one, and this will then result in a new text file, which is titled with the last name of the first author of the first paper we have included, so this one. And if we open it up, then you will see we have now 3 entries here, which look similar to the one from the Web of Science. We need now to do one last step before we can use the Crossref data in creating a research trail, if we didn't already do it. And this is copying the entries we have now put into the same format as the Web of Science output into the Web of Science file. For that, you just copy everything except for the first row. This one needs to stay here because it's already here on the first row, and you just add it at the end in the first new column, in the first new row. You save it, and that's that. Now, there also is a third way to get publications into a research trail. If we look at our flowchart here, it's this one. So this basically means that we take full text PDFs, and by using a different program, a website, get the references out from there and then include them in the research trail. So some publications that we found from Erika Larshan, for instance, this one is neither in the Web of Science nor in Crossref. So, for instance, this is from a symposium, but associated with a publication. Google Scholar often also has the links directly to the full text. We might have to find it. It's here. We can download it. We can download it into our folder of Larshan. I would recommend to create a new folder that you can call whatever you like, maybe PDF, just so you know where the full text PDFs are. So this is one. Sometimes we also have preprints that we can't find in Crossref, but where we can get access to the full text, for instance, this one. You can also then, again, through Google Scholar, go directly to Archive, bioRxiv, download the full text, same as before. And then we'll do the third one as well. All right, now we got 3 PDFs here, full text articles from Erika Larshan, or at least where she's co-author, in different formats. And to be able to use them, we basically need to get these references in a structured way. For that, we go to a site called Growbit. It's a web application of a program that goes through PDFs and extracts metadata, especially references, and saves them in an XML file. We choose process full text document here, consolidate header and consolidate citations, and then we choose the first of our papers, press submit. This will then work a while depending on how long the document is. You can also put books in here, but if you do that, please don't upload the whole book. You need to crop it first, maybe just get the title page and the references, and then upload it. Okay, then we get something like this as the result. This is how the XML file looks. This is the full text, and then you will have a lot of references in this format. What we do is we press download TEE result. We go again to the same folder as the rest, the PDF folder for Lashan, and save it there. And if you go in, you will have a XML file that has the same name as the PDF, but with .te and .xml appended. Now we do the same thing for the other two documents. This will take a while again. Yeah, we get the result again. Download it, save, and the same thing for the third one. Okay. And now we do something very similar to the thing we did with Crossref before. We go into our macros again. We go to macros, and now to add publications instead of add Crossrefs, press run, go into the folder, and we choose again all of our XML files. And then the program might ask you things again. So this is, for instance, the third paper we uploaded. It couldn't automatically extract the name of the first author, the year, and the title. So we give it in manually. If we look at it, it was this one. So it's Erika Larsson, years 2006, and the title can just copy it in from here. Press submit, and then it asks us the same thing again as for Crossref. Do you want to append it or make a new one? This time we say yes. So we directly append it to the Web of Science output, and we choose the one from before where we already added the Crossref stuff. So the one that's called Larshan txt. Press save, and that's done. The last thing we can add to a research trail are patents. So this part down here. In general, this works very similarly to adding full-text PDFs, just with one step in between where we create something like a dummy publication. We've tried several ways, and the easiest way that we found was again to use Google Patents more specifically, where we can then just look for our researcher, or if you already know patents from some publication or website list, directly for the patents or patent numbers. In this case, we cannot find any patents by Erika Larsson. This is quite often the case, not in every field and for every researcher. It makes sense that patents exist. So we will choose a different person, Anton Zeilinger, a recent Nobel laureate from Austria. So this is one of the patents where he was involved with. And the thing that's relevant for us now are non-patent citations. So those parts of the patent where they cite scientific literature. We can also see different versions of this patent. and basically we can go through them and we choose the one where we find the highest number of non-patent citations, which is in this case the US version. You can go here, and this is the thing we're interested in, this part here. And what we do now is we create a dummy publication. We can again make a new folder, call it patents, and we call this something for now. And what I recommend you now to do is to basically create a Word file with 2 pages where you put the references on the second page. Just copy paste them in here. You can format it a bit if you want. And on the first page, you put the title, the abstract, and the authors of the patent. We have the title. Here we have an author list. And then we have the abstract. We've tried a bit around. It doesn't really work to put in a year, so we will have to add that manually afterwards. And for the author list, it works best if you separate them, if you put them in one row and separate them by a comma. Okay, you have the authors here. You can format it a bit if you want, but it's not that important. Okay, so now we have title, authors, abstract, and the references. You save it, and you save it as a PDF. In the best case, just call it how the patent is called. And then you have a dummy publication. And now we can use this publication again, or use this patent thing to do the same thing we did before with the full text PDFs. We choose this one, upload it on Growbit, press submit. This should go quite fast now because it's a small document. We will get the short XML as a result. Download it again. And that's the first part. And for the second part, we go into our Excel file again, press macros, and now we have the third add macro, add patents. We run it, choose our XML, in this case only one, press run. It will get the first author name. It will also get the title. Now we just have to give it the year. This is from 2014 or 2013. Depends what's more important. Let's just put in 2014 here. Press submit, and then we'll ask us again, do we want to add this to an existing output file or a new one? We press no because it's a different researcher. This was just to show you how it's done. And the result is then again a text file, which is rather short because it only has one entry. But if you want to edit, you copy the line again and you would edit here at the end. All right.
In any case, the end result is a text file that we can now use to create the proper research trail. There are again 2 ways to do this. One which can only be used with Web of Science output files, and the other one which can be used both for Web of Science, all the others, and the combination of it. I will show both versions, but then continue afterwards only with the Web of Science version.
We will start with the Web of Science version. So creating a research trail with the Web of Science output file. The difference between the trail Web of Science and the trail extended is that this one has a less complex way of comparing references. So it's quite a lot faster than the other one. but it also is not possible to include all the manually added publications. So we go to macros, trail Web of Science, press run, and now we chose the original Web of Science file, which I called Larshan underscore WOS. Press open, program will do some things, and is finished quite quickly. Depending on how many publications you have in there, how many references they have, and how fast your computer is, this might take a few seconds up to a minute or more. And the result is an Excel file with several sheets down here. The two most important ones are the one called pub table and bibliographic coupling. In pub table, you will have all the publications from your researcher numbered. So there are 43 publications in here. You have some information about them, most importantly, the year, the title, the authors, and in bibliographic coupling, you will basically have a list of links between publications. So bibliographic coupling means it looks at the reference lists of your publications. So for instance, these are all the references in the first publication, and it will compare this to all the references in all the other publications. And if you have the same references or the same reference in two papers, then it will create a link, which we understand to mean something of like similarity. And in this bibliographic coupling sheet, we will run now a second macro, which will help us later. So we go again to View, Macros. This looks now a bit different because we are in a different Excel file now. So this is why the research trail macro and so on is before the name of the macro. Now we'll run count. So it is important that you have both the result Excel file from Larshan open and the original one, the macro file. Press run. This will do a little bit of work now, and you now see in bibliographic coupling it created some new entries. And what these numbers mean is that they give you an idea of how similar or how many links you want to have between two publications to be considered in the same cluster. Because we have to decide that manually when we draw the picture later. So and you can see if we take the lowest threshold, so 0, 0, 1, we will get one cluster and 5 orphans. Orphans mean that these are publications who are not linked with others. You can also see that the first time we will get 2 clusters is with 005, where we have 9 orphans. And then the first time we get 3 clusters is at 009 with 12 orphans. And as a rule of thumb, you want to have a low threshold, a low number of orphans, and a high number of clusters. But at this point, you cannot yet decide which one is the best solutions. So we go ahead with 3 versions. We take one with the 001, one with 005, one with 009, and then see how they will look like. For that, we go again to macros. We choose now create Pajek file network, press run, and now we put in the value. So we said 001, press OK. We do immediately the second one as well, 005, and the third one, 009. It's important to note that depending on what language your operating system has, you either use a dot or a comma here. You need to try that out. Usually for English it's a dot, for German, for instance, as it's in my case, it's a comma. And the results of these macros are now that we will have 6 new files, 2 each for each threshold, which are named after the name of the Excel file and the threshold. So we have Lashan 001, 005, 009. And these are now the input files for Pajek, the program we will use to draw the network. Now, before we go to the next step to Pajek, I will also show you how this works with the extended trail and with manually added publications from Crossref and PDFs. So I put all that we just produced in a new folder called Web of Science. So the output files, the original txt, and the Excel result. So we go into our macro file again. We press macros, and now don't use trail Web of Science, but trail extended. Press run, and we choose now the file where we have added 2 times entries. Press open. This will now definitely take longer than before. And before it starts calculating, it asks us if we want to use a dictionary. It will ask us twice. The idea behind this is that you don't need to manually match references every time. So we now place no, because it's the first time we're doing a research trail on Erika Larshan or even in the field. And now windows like this will pop up frequently. And the idea behind this is that these 2 publications might be similar, but the program cannot decide by itself if it is the same actually. What do these numbers and words mean? So the number at the beginning means from which publication this reference is. So this is a reference from publication 2. This is a reference from publication 8. Name of the author, year, publication name, so usually journal or maybe also edited volume or book, volume, then there's page, and then there would be a DOI. Now these 2 look like they're different publications because they're from a different year, but since we have a DOI, we can actually check that. Usually you immediately get to the page and we see what this is about. And we can also see, for instance, that there is a preprint related to this one, which is from 2020. And if we look at the preprint, we come to bioRxiv again now, we can see that the number of the preprint is the same number that is given as page number here. So these 2 actually refer to the same publication, even though they're from a different year. So we press similar. And similar things will now happen with others as well. Here you can see that there's a slight difference in the name. Also with how the journal is called, this is an abbreviation, but it's the same volume, same page, same year, same author, so we can also say it's similar. Okay, this one is maybe a book. Especially for books, it's not uncommon that the years sometimes, that they give you sometimes different years. But if you look at it, all right, it's a books, it's the name, it's from 1966. The only difference is that he says from 1967. This might actually just be a mistake in the references. So it's not that uncommon. So Web of Science outputs and also automatically create a reference are not perfect. It's not uncommon that there's a mistake in the year, or even more common with books, especially if they are well received, is that there will be reprints of the book or second versions, and then you actually have different years for the same book. So this would also be similar. Now this, guys, also happens frequently. This might be, for instance, a paper in an issue from a journal, and the second one might be, for instance, the introduction. But to be able to check that out, we also use the DOI again.
and look for the paper. We go to the site online. Okay, this is the paper. And then we can check out which publication is at page 5. So we have volume 28. We would go to issue 1 instead of issue 10. Okay, we can see here this paper is page 1 to 10. So this is not the case in this time. So we're still not sure. This might be a mistake. It might be the same paper or it might be a different one. What we can also do is we can check from which publication this is from. So the second one is from publication 8. So here. And you can see this looks a bit different than the others. It has less entries. This is because this is one of the publications we added manually. So we can also go look into the publication directly. So it's a sex-specific something from Ray. We go to Larshan again, PDF, open the first one, and it's actually the first one with this first author. This is the title. We can now go to the reference list, or we can just search for the last name of the author. And we will see that this is actually the same reference. It's volume 28, page 2715, which is the same as up here. So it's the same. Now, this game goes now on. Here we have a similar issue than before. It's again from publication 8. So we can go into the publication and look for the author. And you can see this also appears to be the same publication as the one on top. Yes, so it's similar. And the good thing is now that you only have to do this once for this, because in the background there will be a dictionary written where it will remember that this reference is the same as this reference, and the next time it comes up, it won't ask you again. This was also the thing that it asked us at the beginning. Now here we have a publication from 19. This is not one that we added, so this is also from the Web of Science. Here's just information missing. So we will now have to make the decision as user if we want to be strict or not. Let's just say we're strict. We cannot know if this is the same, so we press it's different. And yeah, the same game will now be done for all of those questions until everything is compared with everything. In this case, although it might again look like it's the same mistake as before, we can actually see that there are two different publications, both in the same journal, also in the same year, but with a different number and a different title. So this is actually a different one. Okay, now you can see by the number of publications, we have 49 publications in total. And now the first one is already at 45, so we are nearing the end. And this is the end actually. Two things. One, this takes much more time than the Web of Science trail. But the second thing is that it's also much more precise. So there are probably a lot of same references that are not established with the other macro, which we can do here. And now we should pre yes. So that means we want to save the Larsen dictionary for matched references. Press save, and now we do it again for non-matched. The reason behind this is that if we would run this again, maybe with one or two added publications, something similar, you wouldn't have to do the same exercise as you would have now. So this is now saved in these files. It looks something like this. And now we are at the same point as we were before with the Web of Science macro. We have again the different Excel sheets, pub table and bibliographic coupling as the more important ones. This is just some extra information that's not really important right now. We can again go to view, count, run, and we will have something similar as before. And again, in addition, what this extended macro can do is it gives you the 10 most cited publications out of all the, so the 10 most cited references out of all the publications you have included here. You don't have to use it, but it might be interesting. And again, if we look at the threshold, we have the same as 005 is the second cluster. Here again, actually, we have at 008 already 3 clusters, and at 009 we have a fourth cluster. So I would say we do the same as before, 1, 5, and 9. So we go to create Pajek file network, 001, 005, and 009. Okay, now we are ready to use Pajek. In both cases, the results are now .vec and .net files, which we'll use to draw the picture in Pajek. From now on, I will only continue with the Web of Science version, but with the extended trail, you would do exactly the same steps. The end result is an SVG file, so a vector graphic, which is the visualization of the research trail. These files are usable by the program called Pajek. If you don't have it yet, you can download it on the university homepage. It's a network visualization tool. You don't have to install it. You can have a portable version of it. What you do is then you start Pajek, and then with networks you open the first .NET. It makes sense to start with the largest number. It will become clear why that is the case. So we open the network, then we also open the vector file, and then we go to network, create partition, components, strong, and we enter 2. So this makes the clusters out of our network. Then with Control Q, we draw our network, and then we can see, okay, we have 4 different colors. 3 of those are clusters, and the teal ones, the blue ones, are what we call orphans. So they are not connected under this threshold. What we can see, okay, we have a red cluster, a green cluster, and a yellow cluster. Now what we do is we fix the x-axis, because the x-axis means the years, and we want to keep the years constant because we want to have some kind of trajectory from the publications. It helps to make the lines a bit more better visible, so you can see more differences. And then what we do is basically we rearrange the publications. So these circles represent publications from the list. We rearrange it in a way that we can differentiate these clusters. If we have more publications in the same year, at least more than 2, it makes sense to move them a little bit in the x-axis just to make it more visible which publication is connected with which other one. Okay, so now what we do is we try to rearrange it a bit. Now that we have somewhat nicely rearranged our clusters, they should be clearly distinguishable. So a red cluster here at the beginning, the yellow cluster in the middle, the green cluster at the top, and the orphans also at the top. The next step would be to export this graphic. There are some options that we can take under export and options. One would be, for instance, to set a black font. People can play around with this a bit, but this usually helps to just make a nicer picture directly from Pajek instead of using a different program afterwards, which you could also do to make a nicer picture in the end. What these options do in particular, you can read in the manual that we also provide. Okay, so now after the options, we go to export 2D, SVG, and general, which will export what we see here as an SVG file. Makes sense to name it after our threshold. Then we press save. And what we also really recommend to do, especially if you have different thresholds, is to save what you did in Pajek as a project file. So file, project file, and save. Then you create a new one for your threshold, because this will make it easier to make comparable pictures with different thresholds. Now what we see as a result here is that we have created 2 files through the SVG, an HTML and SVG file, and a .py project file. If you open up the SVG, we can see that we can see our clusters, but the circles might be a bit too big. So we can go back to Pajek and change the size of the circles, for instance. We do this by drawing it again, which should result in the exact same picture as before. Then we go Options, Size, and change the size of the vertices, which means the circles. We then export it again as an SVG file, and then see if we like it, and if not, we have to work around a little bit. Okay, after the third try, we now have a version that looks okay. It's not too big, and we can still read the numbers. So we choose to go with the size. And then we'll continue from here on with this version. So now we will use the Pajek project file that we saved before This is made up of 4 parts. The first one is the position of the vertices. The second one is the connections between vertices. The third one is the number of the cluster they belong to. And the fourth one is the size of the vertices. And what will be relevant for us here is the first part, the position of the vertices. What we want to do is we want to copy the position of the vertices that we now arranged into the other versions of our network with different clusters. So for that, we create a new Pajek network with a different threshold. Now we take 0.05. We make a new partition again, a strong one, to create the clusters. And then we draw again. And as you can see now, we only have 2 clusters, a green one and the yellow one, with fewer orphans. The position is again quite messy. So what we do is we save this version as a Pajek project file again, which is the 005 project file. We make a copy of it just to be sure. And then is what we do. We copy the position of the 0.09 vertices and override it over the 005 vertices. What you can see here is actually that in the 005 Pajek project file, we already have the stuff from the 09 on it. The reason for this is that we didn't close Pajek in between, so it will keep every project in the project file. So just be sure to have the right threshold open when you copy and paste. So we take it from the 009 and paste it over the positions of the 005. We then save this project file and we open it in Pajek. We load or read it. We now have more entries here, but it should still be fine. And if we draw it, we can see we have the positions that we have created before, but with different colors and different strengths of connections. So from here on, we can make some last corrections, maybe get, for instance, publications 10 and 1 down there, maybe publication 26 up there. But other than that, we already have the settings from before and can easily export the SVG picture. Then we save this again as a Pajek project file to make it easier for the next threshold for 001 to use it again. So we do the whole thing again. We import the net and the vec files for the 001 and we do the exact same thing. Now we have our 3 versions of the network, one with a 001, one with a 005, and one with a 009 threshold, and we can then directly compare those and see how the different publications belong to one or the other cluster, depending on how strict you want to be. But the question which choice would be the best one is actually the most difficult part of making a research trail, and also arguably the one that takes the most of time.
So now we have the basic picture as a vector graphic, and the next step would be to add some additional information to this picture. In the manual, we show 3 ways to do this, one through a program called Inkscape, one through Microsoft Visio, and one through Draw.io. In the video, I'll now only show the version with Draw.io.
And what we would usually like to go along with the research trail is, besides the publications, also something like a timeline where we could see the positions that the researcher had. For this, I personally like to use a program called Draw.io. It's also known as diagrams.net. And here, for instance, you can prepare some kind of templates for a research trail, depending, for instance, if it's a professor that's been in the field for a while, then you just need more space. These are usually on an A4 scale, so you can also print them out and bring them to you for interviews, for instance. And in this case, we will use our template and adapt it for Erika Larsson. So what we do is we just copy paste the SVG as a picture into our Draw.io file. We rescale it a bit so that it fits A4, and then we adapt our timeline to encompass all the years from 2022 to 2001. Now that we have all our years, we will align it by size. So then you can see that every publication on top should fall into the right year. So publication 1, 2, and 3, 2022. Publication 22 is from 2016. Publication 43 is from 2001. Then we come to the point where it's really useful if we have collected some additional information on our researcher, for instance, a CV or anything that you can find on home pages or any academic social media. So we add this kind of information into the research trail. One thing would be the name, and we usually reserve a spot on the top left for that. We also always then write in our research trail what the current cutoff is for bibliographic coupling, so the Salton's cosine that we chose before, and also to write what years we use and from where our publications are. On the bottom, below the years, we would then write the positions. In our case here, we have a PhD position until 2004, a postdoc from 2004 to 2009, and then assistant, and then tenure track to associate professorship from 2010. And now we come to the last part of the research trail, which is also arguably the hardest one, because now we have to assign the different clusters meaningful titles.
At this point, I can only give an idea how it could be done, but in the end, it is about understanding as much as possible about the research.
Now, the main way to do this is by looking at the publications. The good thing is we already have our Excel sheet called pub table, where we have the most important information about our publications collected. One important thing to look for differences and commonalities between publications are the authors, and the other two are the titles and the abstracts. Especially in the natural sciences, the titles already tell us a lot. We usually get some idea, for instance, in biology, what the object on the study is, what the main claim of the paper is, and if that's not enough, the abstract will usually help us out. For instance, in the abstract of the publication 43, we read about Saccharomyces as an object, and more specifically, Saccharomyces cerevisiae, which turn up in more than one abstract and might be closely related to what Eric Galashan was doing in a PhD. Looking up things on Wikipedia is quite common actually, especially if it's the first researcher in a certain topic or in a certain subfield, and you still need to get to know all the common terms in the field. If we have some idea what a certain cluster might be about, it usually helps to create a new layer and then add fields, which we can then color code similarly to the clusters and try to come up with some terms or some descriptions what a cluster is about. After reading more in the abstracts, also in the full text in some cases, you can usually get a bit of a better idea what the cluster might be about, and then refine your topical categorizations. After you're satisfied with the description of the first cluster, you can then go to the next one and then see what the differences are. This now has to be redone for each of the other clusters so that in the end we will have some description of every cluster in the research trail. You can just copy the field from the first one, color it in the right color, bibliographic coupling does not always give us perfect results, so in some cases it might make sense to produce descriptions of subclusters. And after having identified what all the clusters and maybe some of the subclusters are about, we have the descriptions, and then we are basically finished. What we sometimes also like to include, especially for postdocs and younger professors, is also the dissertation, since it is not usually not automatically included in the research trail because it's not a publication on its own, which we could then, like in this case, just include as a text field. At this point in time, we are now done with the research trail. We can now do some more cosmetical things like making fonts bold, making fonts bigger, changing the color of fields, things like this. In the end, we should then have a nice research trail. I usually already do it in an A4 format, so I can export it easily into a printable format, and then we can export it as a PDF file, which is then our end result. Okay, these were now the basic steps to create a research trail with our Excel macros, Pajek and Draw.io. You should always remember that what we produce here are probably not the exact topics that the researcher in question worked on, but we have made very good experiences with using it in interviews and discussing these possible topics with our researchers. You're welcome to have a look into the manual we have on GitHub, or send us or me a message if you have any questions. Thanks for watching.